Now we're going to look at some tables and determine if we have a function based upon examining a table. And so when we're looking at a table of data or a relationship, the top row is going to be the input and the bottom row is going to be the output. Okay? And so in this case, we can see that we input X, we output Y. We're not given a function or a formula for this relationship, so we want to determine if this relationship is in fact a function. So we're going to use the definition of a function to see if we're dealing with just a relationship or if this relationship is in fact a function. So what we want to do is first we want to identify the input and the output values. Like I said, the top row is going to be your input and the bottom row is going to be your output. And so we want to say, okay, so we want to check, does each input, is it paired with only one output? So what I want to do here is I want to scan my inputs. The inputs don't repeat at all, which means that for my outputs, I'm not going to have more than one output. So this, in fact, is a function. Okay, each input is paired with only one output. If I want to write them as ordered pairs, I can say when I input 2, I output 4 right here. When I input 4, I output 7 here. And when I input 6, I output 4. Okay, I can also write that with function notation like we did before. So I can say for this table 1, I can say that f of 2 is equal to 4. That's this point here. I can say f of 4 is equal to 7. And then in my last one, I can say f of 6 is equal to 4. All right, so I input 2, I output 4, etc. So each input has a unique output. So this is a function. If I look at table B here, all right, so I know that these are my inputs on the top. Let me just keep those consistent. All right, these are my input, my X values. So when I scan across, I see an input of 2, 4, 4. I immediately brings to my attention here that I have 2 the same inputs. All right, so I want to make sure if it's a function, I have to have the same output. There can be only one output when I input 4. And so I can already see here that when I input 4, sometimes I get a 5 and sometimes I get a 4. So that single input of 4 has 2 different outputs. All right, so if I write that in function notation, when I input 4, I get a 5. I can write that as an ordered pair, 4, 5. And this says when I input 4, I get an output of 4. So this is not a function. Sometimes when I input 4, I get an output of 5. Sometimes when I input 4, I get an output of 4. So the input 4 has 2 different outputs. This is not a function. And then in my last example here, again, I look at my inputs are in the top row, my outputs are in the bottom row, and when I scan across my inputs, none of them repeat. So that's usually the first thing I look for. Do I have inputs that repeat? I don't. So that means that every input has its own output. I can write that as an ordered pair. When I input 2, I output 7. When I input 4, I output 5. When I input 6, I output 4. All right, each of these ordered pairs goes together, and I could also write them in function notation like I did before. Okay, for this first, I can say f of 2 equals 7. That's in function notation. This is as an ordered pair. This is in a table. I could also graph it. All right, so speaking about graphing, if we are given a graph, and we want to determine if we have a function, we use what we call the vertical line test. Okay, so vertical line test. And really all that means is that if I take a vertical line like this and I sweep it from left to right across my function or my graph, and I want to determine if it's a function, so long as it only crosses in one spot, so no matter where I pull this vertical line, it's only just going through one point. All right, so each input If I look at this, these are my inputs on the horizontal. These are my outputs, okay? So each input has exactly one output. So this first one is, in fact, a function. Okay, so that is a function, yes. So if I look at my next example, and if I sweep it from left to right, this vertical line, almost every single input or x value results in two different y values, right? It crosses the graph in two spots. So for this x value, so for each x value, there's two different y values. This is not a function. And similarly, this last example, right? The only places where it only goes through one point would sort of be at that end and at that extreme end here, all right? But every other x value I put in, I get two different y values. So this is not a function either. That is the vertical line test.